Alright, this is it our first one? No, it's not our first implicit differentiation, but it is the first implicit differentiation on this study guide that asks us to find the second derivative. So I'm going to start with that, and I'll write it over here. So I have y squared equals x cubed. So the first thing I need to do to find the second derivative is find the first derivative, and then I'm going to derive a second time. So to derive this, I do power rule on the y squared. So the key here is I'm deriving the whole thing with respect to x. So that means that I just do normal rules on the x's. And I have to do these weird rules on the y's. But I still have to follow the power rules. So the derivative of the left-hand side, if I do power rule on y squared, I get 2y. But when I do the derivative of the inside, I have a y there, so I need to do, I'll write this first line out, but I'm not going to keep doing it. So I get 2y times dy dx, which I'm going to write as y prime from now on after that. But what I'm saying there is the derivative of this thing is its power rule, so it's 2y times the inside, or the derivative of the inside. That's chain rule. The derivative of the inside here is, the inside is y, so the derivative of the inside with respect to x is exactly dy dx. So that's equal to, all that said, the right side's super easy to derive here. I just do 3x squared. If you say, well, why don't I write dx dx? It's because dx dx is really just 1, right? So if I derive them with respect to x, and then I do this derivative, and I multiply by the derivative inside, well, derivative of how is x changed with respect to x? Well, it's 1. So it doesn't give us any problems there. Anyway, hopefully that helps a little bit, because I think there's been a little bit of, well, why do we do it with this, not that? Anyway, that gives me, I'm going to rewrite that as 2y y prime, because I just like that. I like working with that better, equals 3x squared. So what I'm going to do now is make a little side note. And I'm actually going to do it in a different color so I can keep track of it. If I divide by 2y on both sides, I get y prime equals 3x squared over y squared. The reason why I'm going to do that is because in my next derivative, when I derive this again, I'm going to get y primes, and I want to plug them in. I'm going to leave the old red equation over here and use that to derive a second time, to get a second derivative, because I do not want to do quotient rule if I don't have to. I would rather not make a mistake. High D low, low D high, what comes first? I don't know what's subtracted, whatever, right? I would rather not make a mistake and just use product rule, which I can do on the left-hand side. I don't know if that's how you feel. So, anyway, from here, I've got product rule here. I've got this and that, right? So, now, you know, I'll do this in green, and then I'll do this in blue, so I can point out. So I've got first and second. So the derivative of the first is 2y prime, so that's the derivative of the first, times the second, I get just straight up y prime. Then, if I do the derivative of the second times the first, well, I do plus the derivative of the second, well, that's y double prime, and the derivative of the first is just times 2y. That's the whole derivative of the left-hand side. From here, I derive the right-hand side, and this is super easy with respect to x. It's 6x, and the power drops down to 1, so it's just 6x. So I didn't do this on the study guide, but notice that everything here is divisible by 2. So I'm going to make it easier for myself and write this as y, how am I going to do this. Y prime squared. So I'm going to divide everything by 2. Plus y times y prime, y double prime, so that's this term, is equal to 3x. Now is when I use this green thing here. Notice I've got a y prime and I've got a y prime, so I can substitute this right hand side in for y prime. So I get 3x squared over y squared squared, that's that whole first term, the y prime squared, plus y times y double prime, I'm just going to leave that for now, is equal to 3x. Scroll down. Now I'm done with that green thing. I don't need to worry about it anymore. All I've got is y. There's no first derivative. It's only the second derivative, x's and y's. So now I can solve for this guy. That's my target. I want to know what's that. So let me square this out. I square the do I have, sorry, this is a 2y, is that right? Yep, boo-boo, whoops. I'm 6 minutes in, I'm not going to fix that, but you should notice that I divided by 2y, so there's a 2y there. Alright, so when I square this, I get 9x to the 4th over 4y to the 4th. That's that whole thing squared out, plus y times y double prime equals 3x. Alright, so, I can, there's lots of ways to isolate the answer, but I don't want to have fractions and fractions. So I'm going to multiply everything by that term right there to get, hold on. Alright, I see my mistake. So I wrote, that's not supposed to be there. So come down here, that's not supposed to be there, which means that this is supposed to be squared. Hopefully I don't have any more mistakes. Let me do a little check. I think I'm good. Alright. Sincerest apologies. Alright, so I multiply by the 4y squared. That gives me 9x to the 4th plus 4y cubed, because I multiply y by y squared. Y double prime equals 3x. Actually, I get 3 times 4, which is 12. And then I get xy squared. Take this term, move it over to the right-hand side. And that gives me 4y cubed, y double prime equals 12xy squared minus 9x to the 4th. Last step, I just need to divide by the 4y cubed. Y double prime equals 12x y squared minus 9x to the 4th, all over y cubed with a 4. Is that it? I think that's good. Circle.